Alright, hello everyone. Today we're going to be taking a look at this guy right here. This is a P106-100. This is a 6 gig mining card, and you can tell it's a mining card because it's got no video outputs. And also the cooler is a passive cooler. This one specifically does not have fans, so definitely a mining card. Yeah, I went ahead and did just a quick clean on this card. A lot of these were extremely dirty, so we took care of that and it is ready for us to work on here. So the first thing we'll do is we're going to start with a resistance check. What we're going to do is we're going to check a few things here. I'm going to point them all out and then I'll go ahead and check them. That's going to be the easiest here. So down on the PCIe pins, we have 12 volts, which is going to be any of these first 3 pins down here. And then we're going to have 3.3 volts, which is going to be the 4th pin from the right side. And both of these are on the small connector. The next thing we're going to check is going to be 5 volts, which is this guy right over here. Hopefully you can see that all right. This guy. And then the large tab is going to be the output in this case. Then we're going to check this guy right here. This inductor is for 1.8 volts. Then we'll check this smaller inductor right here. This guy is for PEX. Right there. And then we'll also go ahead and check the 8 pin. We can just check that on the shunt right here. And then we'll go ahead and check vCore, which is going to be these 4 inductors right here. And they're all connected on these inductors, so we just need to check one. And then we need to check memory, which is the bottom guy right here. So let's go ahead and take a look at all of those. Alright, so you should be able to see my multimeter in the upper right of the screen right there. So we are looking at the PCIe slot currently. This is that small connector here, and we're on the front side. So here's the large connector, there's the tab. So we'll go all the way over to the left right here. And then again, we're going to start with 12 volts and 3.3 volts here. So I'm going to place one probe on ground. This card doesn't have a super good ground. Normally I would use the IO shield, but it obviously doesn't have one. So I've just picked a capacitor that goes to ground, and I've picked the ground side of that capacitor. You can pick just about any ground on this card. You could pick a ground that's down here, doesn't matter as long as it's on ground. So what we're going to want to do is we're going to stick our other probe on any of these 3 first pins. And as you can see on the meter, we're getting 30 kiloohms, 36 kiloohms. That's plenty good. And then we're going to count 4 from the right side here. 1, 2, 3, and 4. And that's going to be 3.3 volts. And again, we're like 26 kiloohms, so that's plenty. The next thing we can check is that 5 volts right here on this guy. Probe on ground, and the tab is the output in this case. So let's see what we get. It should be around 500, 476 ohms. That is plenty good. Now we can move up more and over here a little, and we can go to 1.8 volts, this inductor right here. And we want to be seeing, that's about right, 835 ohms. That should be plenty good. Then we'll check the one to the right of that. This one is for PEX. And we should be at about, 57 ohms. That's a fine rating for this guy. So that is totally good there. And then, like I said, we need to check these inductors. Oh, actually, you know what? Let's check this shunt really quick and make sure we don't have a shorted 12 volt. Shorted 6 pin. Do we? No, that's totally fine. We got 2 kiloohms, 3 kiloohms, and rising. We're good there. So let's flip the card over, and we will go to these inductors on the back. This bottommost one is going to be memory. And then the other 4 are going to be vCore. So we can start with memory. Let's find a ground plane on the back side here. So let's check memory. We are looking at 40 ohms, and we have got, what kind of memory on here? We've got Samsung, so that is plenty good for Samsung. And then we will want to check our vCore, one of these guys. And these are going to be a really low reading. Don't worry, it's not a short. 0.2 ohms. Yeah, we're pretty. It's going to be pretty close to 0, and that's totally normal. So everything looks normal on this card as far as I can tell. Let's go ahead and toss it on a riser, and then we'll take a look and see if the core is getting warm and if we're getting any voltages, or if we're missing any voltages anywhere. We can go through the voltage sequencing for this card, and that'll help us figure out what's going on. Okay, so we've got it hooked up to a riser. Let's go ahead and power the PC on, and I'm going to just stick my finger on the core here. We're going to see if it gets warm at all. And it's not really getting warm at all. Okay, so let's see. Let's check with the meter and see if we have any vCore voltage. My guess is we do not, since it's not getting warm at all. Switch to voltage mode here. And yeah, we have got no vCore voltage. Okay, so of course we don't have MEM either. Alright, so now we're going to go ahead and use the power sequencing chart, and that's going to help us figure out what voltage rail we're missing. We want to make sure we're not missing anything before vCore. If we're missing anything before vCore, then vCore will not power on because we're missing that rail. As you can see on the left side, we're looking at the 1000 to 3000 series NVIDIA. So in this case, we want to make sure we've got 3.3 volts and 12 volts. So 3.3 volts is going to come from the PCIe, and then we want to make sure we have 12 volts from both the PCIe and the 6-pin up here. And then next, we're going to be looking at 5 volts, then 1V8 AON, and then NVVDD, which is vCore, then PEX VDD, which is that PEX up here, and then last is going to be FBVDDQ, which is VMEM, or memory voltage. So first off, we'll just double check and make sure that we've got 3.3 volts and 12 volts coming through. We should have both of those since they're both externally generated, but it's always a good idea to check. Okay, so we are back under the scope now, and I am looking at the bottom where the PCIe connector is, as you can see here. So we're going to go ahead and check 12 volts just right on this shunt resistor right here. One probe on ground, one probe on either side of the resistor. And yep, we've got 12.4 volts, so that is plenty good. And then next we'll go ahead and check 3.3 volts. So on this guy right here, we'll just make sure that it is coming in. Yep, it is indeed coming in. It's probably not a bad idea to make sure that it's actually making it through to other components as well, but for now I'm just going to make sure that it's actually reaching the board and being generated by the riser that I've got it on. So next what we want to check is the 5 volts right here. So as a reminder, this tab is the output right here. This board is looking a little disgusting, but that's okay. And as you can see, we've got 5.18 volts, so that is plenty good there. And then the last thing that we need to check here before vCore is going to be 1.8 volts. So let's see if we've got that. And yes, we do have 1.8 volts. Okay, so since we've got everything leading up to vCore, vCore is going to be the next rail to boot, then we don't have to worry about another rail being gone. All we need to worry about is this guy right here, which is our main PWM controller for vCore. In this case, we're looking at a UP9511Q. I've added a pinout of this component that we're looking at right here on screen that you can see on the right side. This is a UP9511Q. There's not a readily available datasheet for it, but luckily it is on this one schematic, so it's a little low quality, but hopefully you can see that. So the first things we want to check on here are going to be our enable signal and the 5VCC. So 5VCC is going to be pin 10, so let's go ahead and check that. This is going to be the first pin right here. It's signified by this little arrow, and there's a little dot on the chip that lines up with this slanted or angled corner right here. That's how we know that's going to be our first pin right here. So there are 8 pins per side, and again we're looking for pin 10. So we'll go 8, 9, and then 10. So 10 is going to be this guy right here. Let me stick my probe in there without hitting anything else, and we do have 5 volts, so we're good there. The next pin that we want to check is enable, and enable is going to be pin 30. So we've got 32 pins total, so if we go 32, 31, and 30, this is going to be enable right here. And it looks like we are indeed missing enable. So that is going to be what we're going to need to investigate now. If we want this controller to power on and output voltage to the MOSFETs for vCore, we definitely need enable. Okay, so now that we know that we don't have any voltage on enable, the other thing we want to do really quick is check that same pin with resistance mode. We want to see if it's being pulled to ground or if we're just missing a voltage somewhere. So if we probe this guy, let's see, watch the meter, we're at, yeah, just 1.5 ohms basically. So it is essentially being pulled to ground here. We're probably going to want to look for a dual NPN transistor is probably what this enable pin is going to go to next. Unfortunately, I don't have any sort of schematic or board view or anything for this card, so I'm going to have to manually trace it. Give me a minute here, I'll take a look and we will come right back. Okay, so I've done a little bit of poking and it turns out it is just this guy right here, which is right on the reverse side. Here is the controller, and if I just flip it right over, it is right here. Okay, so it is connected to this guy right here, and then these two pins are joined together via a trace on the board. This is a dual NPN transistor package. So what we want to do, basically, I'll have to make a separate video on how these actually work, but I'll do a brief explanation for now. So this is ground and this is ground right here. So basically what happens is when we have voltage on these guys over here, since they're joined together, that pulls this guy, which is our enable signal, to ground. So as we saw earlier, it is being pulled to ground, so that is being done by this guy. What we want to happen is this middle pin right here to have power. When we have power on this guy, then that pulls these two to ground, which is this guy right here. It allows voltage to flow through there to ground. And then that means we have no voltage here. So then this guy, which is again our enable signal, is no longer being pulled to ground, and that voltage can flow all the way through to enable. So let's power the card back on. And what we'll do is we will check these two pins right here. I'm assuming we're going to have voltage, but we'll take a quick look and make sure. So this should be our EN. We should be 0 volts. Yep, that's correct. And these guys right here are 5 volts. Yep, so just like I thought, we've got 5 volts on these guys. And then if we check this middle pin on the side over here, we have 0 volts. Yes. So the next step would be to trace this middle pin here. As we can see, it just goes smack into a via there. So I'll have to figure out where that goes again. The next stop for this is most likely going to be an AND gate. That's where this voltage is going to be generated from. So I'm going to look for an AND gate that this connects to, and then I will come back as soon as I've found that. It looks like I didn't have to go far to find a connection. So we're going from that middle pin, and it connects to this side of the resistor right here. If I stick one probe on here, and I stick one probe on there, I get a beep. I couldn't find anything else that connects to the same side, but I noticed that through this resistor there is another trace right here. This comes off of here, but these are connected, so this is connected to that trace. So I'm going to now probe that side of the trace and see if I can figure out where this goes. So I have done a bit of probing, and it does in fact go to this AND gate right here. It's going to connect to this output right here. Obviously, if I probe the EN pin, we're not going to get anything over there because the resistance is too high for beep mode, continuity mode. But if I probed the other side of that resistor on the back, then we would indeed get a beep. So the next thing we're going to do is we're going to power this on. These two pins right here are inputs. This guy is ground. This guy is power for the AND gate. And then that is the output. So what we're going to do is we're going to check both of these inputs, and we're going to see what we have on those. My guess is we're missing one, possibly both, but most likely just missing one of those. So let's go ahead and power it on, and we'll take a look here. So now that we're powered back on, we are in voltage mode on the multimeter. So we'll go ahead and take a look. Let's probe this bottom left pin. And we've got 680 millivolts. And the middle one, we've got 1.8 volts. So the middle one is probably good, but it looks like this one right here, 680 millivolts, is not going to be high enough to give us an output. As you can see, there's no output over here. So the next thing we're going to do is trace this guy. Let me zoom in a little bit. So taking a look at this guy, I'm going to check this in voltage mode, and we can just make sure that these connect. Yeah, 675 millivolts there. So that is a good connection with this AND gate over here. Now we can take a look at this pin right here, and that guy is 700 millivolts. So 700 millivolts is enough to pull either one or both of these to ground, depending on how they have this set up. So I don't think this guy is being pulled to ground. Let's take a quick look and just make sure. What's our resistance on this guy? Yeah, it's 0L. So this is definitely not being pulled to ground. So I think it's safe to conclude that this guy is not our problem. This is not producing the voltage for the record. This is just another, it kind of acts the same as that first dual NPN transistor package that we looked at. It'll pull the signal to ground if something is wrong. So I'm going to take a look and see if I can figure out where this via goes. And as soon as I find that, I will come right back. So we are back on the back side of the board again. On pin 1 of that AND gate, which is the one that's 675 millivolts, which is too low, it connects to this guy right here and this guy right here. So now what we'll do is we'll go ahead and power this on, and we'll check all 4 of these pins, and we will see, my guess is that one of these is going to be low or pulled to ground, and we'll see which one, and then we can continue to trace that back a little further. So we are powered up, we're in voltage mode. We can go ahead and check these guys. Let's first just check the output here. So that one's 675, and oh, they're both 675. Okay, let's see here. That one's 1.8. That one's 1.8. That one's 0.675. And that one's 3.3. Alright, so we have found our culprit. It is this guy right here on this right D507, the left leg of D507. Let me take a look and see where that goes, and then I will come right back. So I did some poking around, and it looks like we've got continuity to this guy and this guy right here. So these are diodes, dual diodes. And these will pull down our signal for that AND gate if something is wrong. So we can do some probing around these. And these two are typically powered by a pull-up resistor that's hooked up to 3.3 volts. I think it's this guy right here. So that guy is connected to both of them. That's the only one I can see, and it goes to another via right here. Let's check to see if that's being pulled down to ground at all. Let's first, in this case, check the resistance with it off. We have 16.4K. So now if we power this back on, we had 16.4K with it off, and we have mega ohms with it on. So it's definitely not being pulled to ground. Do we have 3.3 volts on this side? No, we also only have 675 millivolts on that side. Okay. So I think this is our pull-up resistor. I've taken another quick look at this as well, and this pin right here is actually powered by this resistor right here, which comes from the same thing. And I would wager that since this is 3.3 volts, this right one, I'm pretty sure we want 3.3 volts on the left one as well. And of course we want 3.3 volts on the outputs. Since it's not being pulled to ground, I think it's just a problem with our source voltage, which, if I'm not mistaken, is going to be NV3V3 in this case. So let me take a look at that, and then I will come right back. So, let's take a look at the bottom left corner of this PCB. As you can tell, there is just a little bit of damage down here. For the record, I noticed this before I even started, but I think it's about time we replace all of these. There are a handful of components in this area that may be affecting our diagnosis. So I'm going to go ahead and repair all these. We'll probably just do a little time lapse. As you can see, I've got a few missing components. I have this guy right here, this guy right here, this guy with a missing pad, this guy right here, this guy right here, and this guy right here also with the missing pad. So we'll go ahead and take care of those, and then after that we'll check again and see if we still have 675 millivolts on that diode. If we do, then we'll continue with the diagnosis and figure out where that NV3V3 is coming from. Okay, so we are all finished up with this. We got some repairs done here, replaced some components. I just took all these off of another dead card. And I had to run 2 jumper wires there, as you can see. This is 32 gauge wire, just in case you wanted to know. And yeah, we got everything replaced here. So let's connect this back up to power again really quick, and then let's see if anything changed. There are a couple other busted off components, but they seem to be from memory as far as I can tell, so I don't think those would affect anything here. And then let's jump back over to voltage mode. And this time, let's take a look and see. What do we have out of here now? 3.3 volts and 3.3 volts. Perfect. Okay, so now let's flip it back over. I can already feel that that core is a little warm. But let's see. I'm going to flip it back over and check the voltage in a second, so I'm not going to switch over to the other camera. But yeah, that's already getting warm. So if we flip it over, and then we can check, and we're fine keeping this on for just a second. Don't want to leave it on any longer than we need to. So yeah, 850 millivolts. If we check the very bottom phase, 1.55 volts, so that should be good. And yeah, so we've got all voltages now. So we have everything up through vCore, PEX, and memory. So that is the boot order. So we get the full boot order, core is getting warm. And now the last thing to do is see if this card functions. So let me hop out of the microscope view. Let me grab a cooler. We'll toss a cooler on here, and I will stick an external fan on it as well. And then we will jump over to Windows. We'll see if it shows up in Windows, and then we'll go from there. So we're back on the overhead view here. Instead of putting a cooler on, this card really isn't going to heat up at all unless I'm mining or anything on it. I just want to see if it detects in Windows. So I've got an external Intel fan here that I just power via my bench power supply. You can see the cables over there. So I'll go ahead and turn that on. This thing at full power will definitely keep this cool enough. And we'll kick this on. And then we'll jump over to Windows and we will take a look at what's going on here. Okay, so here we are in Windows. I'm just going to go ahead and open up Device Manager, and we'll pop out the Display Adapters section. And as you can see, we've got the P106 right here. If we double click on that, it looks like there aren't any errors or anything, so we are all good to go there. Go ahead and pop open GPU-Z, and we'll swap over to the P106. And we'll take a look here as well. Looks like everything is populated. It's showing the memory, the amount of memory. We've got the BIOS in here, the clocks, everything looks good. If we go to the sensors tab, we can see It's at 139 megahertz. That's standard for not mining or anything. And you can also see it's got all the voltages and everything here. So yeah, looks like everything is good to go there. Okay, so as you saw, the card is showing up in Windows. Everything is looking good in GPU-Z. So it seems like the only problem was just those busted components off the backside. There are a few more for memory that I said I'll go ahead and replace those. They're just capacitors, so I'll take care of that. And then I'll go ahead and toss a cooler on it, and I will actually get it mining. And we'll see if it's fully working, make sure it doesn't have any other issues. I don't think it will. And then, yeah, we'll be good to go. Also, just to clarify why I did a diagnosis before just replacing those busted off components, even though I knew they were there from the start. The reason I did that is because if I were to just replace all those components, that is some time that I have to put into the card, and then it could potentially be just a straight up dead card. So it's a better idea to do a diagnosis of the card, figure out what's wrong. In this case, I wanted to show off how I would diagnose Enable, so I traced it back a little bit and then determined that that was probably the source of my issues. So at that point, I was willing to spend the time to replace all those components, and then, of course, that did solve our issue in this case. So, yep, let's swap back over once I've got a cooler on, and we'll make sure mine's good, and then we will finish out the video. Alright, so I have got HiveOS pulled up at this point. We have got the cooler back on the card. I took care of those few components on the back. I've got a fan on it. You can actually see that's the live video running in the background. And then I've got just a live screenshot of my HiveOS up there. So yeah, you can see I just tossed some quick overclocks that I found on it. I can't remember what I was using before. So we're at 23.17 megahashes per second. But yeah, it's been running for about 20 minutes now nonstop, and it's been doing great. So it looks like just those busted off components were the source of our enable problem. And then additionally, the extra couple components that I had on the back, those are just going to be caps for memory. So yeah, those are taken care of, and yeah, that's the video. So thank you guys for watching. Hopefully I'll have some more coming up soon. These take a little while to record, edit, and get out. I can't repair stuff nearly as fast as I can when I'm just fixing off video on my own, but I'll do my best to get some more out for you guys. So I think the next video coming will be a drilled card. I've got a handful, these same cards, the P106-100s that have shorts, some dead power stages, and they need to be drilled and removed, and yeah, so that should be fun. But anyways, thanks for watching, and I'll see you guys next time.